Welcome, everyone, to our Self-Driven Women event. My name is Allison Thackston, and I'm an engineer at Waymo working on Waymo's Planner, the software that allows our driving technology, the Waymo Driver, to plan its route from A to B. This is the third event in our Self-Driven Women series, fostering a community of women working on the cutting edge of mobility technologies. We had an excellent reception to our first two events and about how women can build an impactful career in autonomous driving and the role of mentors to help them get there. Today, though, we're doing something a little different. We're going to shine a light on the technical work that we have been doing to help achieve Waymo's mission, to make it safer and easier for people and goods to get to where they're going. To do that, we'll be giving you a glimpse inside the technologies powering the Waymo's Driver. Each of us will share more about the work we do building the autonomous driving technology stack that powers Waymo's operations in both ride-hailing and trucking. Along the way, you'll also learn more about how we got started in our careers and why we think a career in autonomous driving technology can have such a huge impact on the world. I'm delighted to be joined by two esteemed colleagues today. Congcong Li is a director of engineering on our perception team, helping the Waymo Driver perceive and understand the world around it. Congcong, hello.
Hello, everyone. Great to be here.
Congcong, to put it simply, perception technology is what makes it possible for the Waymo Driver to tell the difference between a pedestrian, a tree, and a pedestrian carrying a Christmas tree. Is that right?
Yeah, that's correct. We can also help the Waymo Driver to tell the difference between a skeleton decoration and a trick-or-treater tool.
That feels pretty important this close to Halloween. We're also joined by Shilpa Gulati, our head of behavior prediction, the software that allows the Waymo Driver to predict the behavior of other road users. Shilpa, welcome.
Thank you. Very happy to be here.
Shilpa, your team helps the Waymo Driver work out what the other road users are going to do next, right?
That's right. For example, behavior prediction software allows the Waymo Driver to work out whether a pedestrian walking towards the crosswalk is going to cross in front of us or behind us.
Thank you both. We're very excited to have you both with us. The 3 Ps the three of us work on, perception, prediction, and planning, are essential for any autonomous vehicle to drive successfully. They allow Waymo's vehicles to answer basic questions like, what's happening around me, what's going to happen next, and what should I do as a result to help me get from A to B successfully and safely. During today's talks, Congcong, Shilpa, and I will each explain how each P we work on helps the Waymo Driver drive successfully. By the end, we hope you will have a deeper understanding of why autonomous driving technologies are so complex and sophisticated, and why they're such an interesting challenge to work on. Before we start, a few points of housekeeping. You'll see there's a chat function for you to leave comments. We want this to be a two-way dialogue, not a one-way presentation. So please do use it to leave us your thoughts and questions so we can have a rich conversation about the importance of autonomous driving technologies and how they work. Closed captioning is available on demand. Click the settings button in the lower right corner of your video window to enable it. Shilpa, Congcong, before we dive into the technology, I wanted to talk about your role at Waymo and your career journey getting here. Congcong, you've worked with so many different teams at Waymo and previously at Google, including image search and photos. Have you always been interested in a career in technology? How did you join the technology industry and come to find yourself at Waymo?
Yeah, that's a good question. Thanks, Allison. Yeah, I can share my experience. I developed a strong passion in computer vision and machine learning during my undergraduate study. And then I pursued my PhD with a focus in those areas. And I was very fortunate that to get the opportunity to integrate some of the algorithms I developed into a robot during my PhD to help the robots to move and around the room and also accurately pick up objects in the room. So those actually become the seeds for my later career here in Waymo. So after my PhD, I first joined Google to work on image understanding algorithms to help improving Google image search and photo search, where I earned the experience of landing state-of-the-art machine learning techniques into popular real-life products. And from there, I also learned how important it is to develop a scalable system in order to allow a faster iteration on a very complex system like search. So all my learnings there have impacted my approach in viewing and tackling the self-driving problem here. And when I was working in Google, I saw the self-driving project taking off. And I found that I can connect all my past experience together in computer vision, machine learning, large-scale data, complex systems, and real user impacts with the single product self-driving car. And I felt so excited about its revolutionary mission. So therefore, I joined the project in 2015 to start my journey here. And it's my great honor to accompany the team since then, from a research project to become an alphabet company, and then now to ship the full driverless service to the public in Phoenix, and also now scaling our products to more users, more cities, and more applications, including the truck. So it's super exciting journey. And yeah, happy to share more here today.
Wow, yeah, that sounds like quite the career journey. I'm super glad you're at Waymo now. Shilpa, you and I have discussed in the past how you decided in your teens that you wanted to become an engineer after reading Isaac Asimov's Robot series. I've always found that really admirable about you, that you alighted to such an ambitious career at a young age and found a route to make it a reality. What was your journey between that moment when you were in your teens and where you are now?
Allison, as you mentioned, I got interested in the idea of robot brains in my teens. Of course, I did not know at the time what a career in robotics would look like. I did not even know such a career existed. This was pre-internet days, and so it wasn't easy to just look up on your phone, what's going on in the world. I was drawn to physics and math with some vague sense that, if you want to build intelligent robots, you do need these subjects. So I did that, and then I pursued a degree in mechanical engineering where I built a pick and place robot. So at that time, I was focusing more on the hardware of robotics. It was during my PhD at UT Austin that I took a few courses in robotics in the computer science department and discovered I just loved those. So, therefore, I continued pursuing those and wrote my PhD thesis on motion planning for an intelligent wheelchair for people with disabilities. So, when I graduated with my PhD, the Google self driving car project was well underway, and the potential for fully driverless vehicles to have a positive impact on people's everyday lives was starting to be recognized. So, with this potential, to make roads safer and save many lives, autonomous driving seemed just like the best place for me to apply my knowledge and finally make my dream of building robots a reality. So I started in the AV industry, worked for several different companies, acquiring a breadth of knowledge, and finally landed at Waymo with both of you. It's a role that continues to provide me new challenges and learning every day. So as to echo what Song Song said, really exciting. Um, and speaking of which, Allison, how did you end up at Waymo?
Yeah, actually, it's really interesting. I started out in signal and image processing, where I was involved in things like algorithm development and data collection. But I've always really been interested in robots. Like I was really into Star Wars as a kid. I had done some robotics work in various clubs, like at school, and at some point I just decided I wanted to do more of that. So I pursued a degree. It was actually a degree in mechanical engineering, and it focused on robotics, where I explored underwater manipulation with human intervention. This later led to joining NASA on the Robonaut project. And there I got to do manipulation in space, which was really fun. I also helped create the software architecture that would be used in the newly upgraded Robonaut that was compatible with ROS, which is an open source robotics framework. The software was built with safety in mind and was later safety certified to run on board the space station without a motion stop, which was a big accomplishment. I later spent some time working in the applied research domain on home robotics, and it's been really exciting to see how far robotics has come. What really got me interested in Waymo was the opportunity to work on a product that would have an impact on people's everyday lives. It's incredibly challenging work, and I'm able to use my background in planning with safety at its core and real-time systems. And of course, by working at Waymo, I get to work with some of the top people in the field, including you two. All three of us, of course, ended up at Waymo working on autonomous driving technologies, but what's been the biggest transition? For me, it was going from applied research to a product, and it's actually been really nice. The transition to focusing more on the customer makes each change just a little bit more meaningful because I know that someone will appreciate it. But there's definitely a lot more that goes along with developing an autonomous vehicle for the public than a robot in a research lab. There's like a lot more testing, a lot more verification and validation. And my experience at NASA has been particularly useful to understand the key role that plays. What about you, Song? How did you make the leap over from image searching?
Yeah, there are definitely many unique changes in image search or in self-driving. But actually, I figured that like, there are actually a lot of concepts shared between the two as well. So if you view image search as a problem of like retrieving the best images for a user query, the self-driving car can be viewed as a problem of like retrieving the best set of paths given your destination and understanding of the environment. So both of them require the understanding of the content from images or sensor data. So a lot of perception algorithms and techniques are shared. And both industries also start with like a lot of like heuristic-based approaches, and then in recent years moving to more and more machine learning, especially with the blooming of deep learning techniques. So many of the knowledge and technologies in those areas, such as like object detection, classification, and machine learning techniques like domain adaptation, data augmentation, they just naturally translate from one to the other. And also, more importantly, as I mentioned before, from image search, I really learned that it seems important to build a scalable infrastructure to enable fast iteration on the solutions, as technology is always advancing very fast. So we need to be able to have the ability to adapt very quickly, and that's shared across both industries. Yeah, I would like to hear about from you guys, like your experience here too, like Shilpa.
Yeah,
So,
Shilpa,
no, go ahead, Allison.
Okay, I was going to say, I know that you previously worked on intelligent wheelchairs and then the autonomous underwater vehicles and the NASA projects. Did you find that autonomous driving was a hard transition, or were the fundamentals largely the same?
Yeah, so intelligent wheelchairs and autonomous underwater vehicles, they are different types of robots. The environment they work on is quite different. Wheelchairs work in indoor environments with slow moving obstacles. Underwater vehicles don't deal with as many obstacles, but they have to deal with water currents, temperature gradations, etc. Yet they all need the ability to perceive, predict, and plan. I found that all the knowledge I acquired during these projects, as well as my work in the industry, it fits into a big picture. This big picture consists of thinking through the fundamental problem formulation, the math to solve these problems, the software to implement the math, and the verification and validation method to test the robot. So while I continue to learn new techniques as they emerge, like as Song Song said, this field is continuously evolving. I still find that the fundamentals in math, physics, computer science, and engineering stay the same and help me build my knowledge very quickly.
Cool. Yeah, it sounds like we've all had really good transitions into autonomous vehicles and Waymo. But I want to know, what was it like being a female engineer when you started out compared to now? Have you seen any major shifts in the industry over time? Song,
Yeah,
why don't you go first?
I can share my perspective. Like, I was one of the very few women engineers in Waymo when I joined the project in 2015. And now I saw women at every level across like different functional teams in Waymo. And over time, I have been observing our leads are very committed to improve the equity, inclusion, and diversity in the company. So, for example, we have sponsored like engineers to attend various events like Grace Hopper and others, and also encourage us to present in those events to help more women around the world to understand self-driving and the diverse skill sets we need in this industry. Also, as a women engineer in Waymo, I got access to a variety of mentoring programs to support my career development, which I really appreciate that. And just one more thing too, we also have an internal organization called Women of Waymo, where we as women support each other, and we also got a lot of support from our men allies as well.
And
Yeah,
so
that's
to
my
share my
learnings.
experience, yeah, thanks, Song Song. Like, so my experience is similar to yours. When I started out over a decade ago, I didn't start in Waymo, I started in the industry. I was often the only woman engineer on a project, and in the room, there was little discussion of equity, inclusion, and diversity, or EID, of hiring and retaining a diverse group of people, and of the impact of generous parental leave on retention. Things have changed quite a lot since then. At Waymo, there are women at all levels of engineering, from fresh out of college engineers to middle and senior managers, all the way to our CEO. Further, these women have a diverse set of backgrounds and come from many parts of the world. EID is part of the core values of Waymo, and there are many policies in support to support Waymonauts in their career journey. For me, all these factors have made me feel empowered. I have been able to bring my authentic self to work, and I feel fearless in taking on challenging projects and also to evolve my technical and leadership skills. What has your experience been, Allison?
Yeah, my experience, I think, echoes both of yours. Also when I started out, I was often the only woman in the room. And now at Waymo, I definitely see women at every level, just like you said, Shilpa. It's certainly for me been a welcome change to go from being told that like women don't make good engineers, which really did happen to me in my first job, to working with top engineers at Waymo who also happen to be women. And knowing that Waymo supports EID and holds that as a really core value has even led me to feeling empowered to take on something like a board position in the Women in Robotics nonprofit organization. It's important for me that women have the support that we need to feel successful, not just at Waymo, but in the industry as well. How do you view the future of women in AV/sim careers? Do you think that the changes you've seen over your career will continue?
Yeah, I think the awareness of the importance of EID in business will continue to increase as we see greater sense of engagement, belonging, and purpose from employees, and hence better overall retention and long-term success of organizations that support EID. The implementation of EID policies is complex. It needs many iterations. We are all learning, but we will get there. We are improving with time. So I am very optimistic that this trajectory will continue. And of course, as women, we have a key role to play in this industry by advocating for ourselves, by being allies with each other and other underrepresented groups, and by driving change when we are in a position to do so. What do you think,
Yeah,
Samsung?
I completely agree with what you said, Shilpa. I also agree that like EID is a really long journey and it would need efforts from everywhere in the society. There are things that we can start with, such as advocating for ourselves, supporting for each other, and also raising more awareness of EID in our hiring and people development programs, and many other things. So I think each of these are just a small step, but just that like cumulatively we will make a difference. So we'll just take small steps now and hoping we can have a bigger difference over time. How about you, Allison? What do you think?
Yeah, I definitely have a lot of hope that it will continue. As organizations fight for talent, I think those that have policies that support better work-life balance will end up having greater success. And it just so happens that policies that support better work-life balance also tends to support women better. Things like more generous parental leave policies and more flexible working hours make it much easier to balance all the different facets of your life. Now, the three of us work in the technical side of our organization, the engineering breakthroughs that make it possible to build the Waymo Driver. What was the hardest technical challenge you've worked on in your career? And what's the eureka moment you're the most proud of? Congcong?
Yeah, good question. Like hardest challenge. I think actually like the thing that has excited me all the time in this industry and in Waymo is that like it's always the current problems I'm dealing with are the hardest challenges I have ever experienced. So for example, the first challenge I worked on since joining was to launch the driver's ride in Austin, Texas in 2015, which was known to be the world's first fully autonomous ride on public roads with our friend Steve Mahan, who is legally blind in the car. And even it was just one ride, right? So since it was on the public road, and you can't control what can happen on the road. So we need to nail the problem to be able to handle all kinds of long-tail possibilities on the road. So that was like, but still that was a relatively easy route and environment. So then the next challenge comes, which was to launch the driverless fleet in Phoenix, operating in a much larger region, 24/7. And then later it comes the further challenge of like opening the service to the public, requiring further higher standards in the ride smoothness and many other customer aspects. So now again, we are tackling the most challenging problems ever, which is to scale our service to more complex environments like dense urbans like San Francisco, to scale it to more weather conditions, as well as like simultaneously scaling to other applications like Waymo Via, which is the autonomous trucking platform. So all this just like every time I meet a new challenge, it's the more difficult challenge than ever before. And in terms of like overall these challenges, like I feel the very best moment I had is that like always in sitting in the car. So feeling the improvements over time, and that get me always excited. So a few days ago, I showed a Waymo video to my 2-year-old, and then she saw the empty driver's seat, and she asked me that like, who is driving that car? And I told her that like, the car drives itself, and she answered me with her favorite phrase, "Really? Seriously?" So that was her favorite phrase, and she always said that. And yeah, it was quite fun. Like when you have opportunity to share that with your family. Yeah.
That's wonderful song. We are all getting our kids started early on learning about autonomous vehicles. um, so for me, also, I like Allison. I have worked on many types of robot. I worked on an underwater robot, which we tested in an ice-covered lake in Antarctica, and that was challenging in its own way in terms of operations and deployment. But clearly, in terms of the technical complexity, for me, I have worked in prediction and planning of autonomous vehicles, and they take the cake. The sheer complexity of the problem is just amazing, and I fondly remember all the interesting problems we were solving to make our rider-only service with Waymo One available to our customers in Phoenix. We had to understand the problem space deeply, and retrain the models till we got the performance we desired. And of course, we had to solve the long tail of problems. And in 2019, I traveled to Phoenix to experience the ride myself before it was like launched. There I got the experience. There I experienced how our models performed in real life. I had the Waymo driver drive me to several destinations. I changed the destinations while I drove. It handled all kinds of complex situation, and very soon I was very much at ease, just chatting around. And in fact, like Song, I am very much trying to inculcate engineering into my child. So I took my 5-year-old son with me. He remembers the experience and tells everyone that he has taken a ride in some of the first autonomously driven vehicles ever. And that to me is priceless. Allison, how about
Yeah,
you?
that sounds really, really fun. I can't wait to take my kid into an autonomous drive car as well. I guess for me, I think the hardest technical challenge is definitely the one that I work on at Waymo. Like autonomous driving is just incredibly challenging. However, I think maybe the most unique challenge, and the one I'll share with you today, is working on getting Robonaut, which is this big humanoid robot, to move around a mock International Space Station. A lot of things went into this. We had to mimic gravity. In order to do that, we tested inside of an artificial gravity offload facility, which is basically a big robot that compensates for gravity in the center of mass of an object. Because it's only on the center of mass, and we are testing, we did test on Earth, right? We had to model actually hybrid gravity, where gravity was offloaded from the center of mass, but not for any of the outstretched, appendages. So things like the climbing legs obviously experience gravity. And then using that system to really test how the robot would move, its limbs would grapple to the handrails that were inside of a mock station to navigate from one side of the station to another. And so even in this kind of like mock task, of course, it's done on Earth, a lot of things can go wrong. So just like climbing a rock wall, like one misgrasp of the handrail could result in a much more difficult traversal because of the limited number of handrails that are present. And due to the dynamics of the test facility and the precision required in order to like successfully grasp a handrail, we actually had to use a hybrid approach of planning and reaction. This ended up increasing the robustness of our solution dramatically, which enabled Robonaut to successfully maneuver around this mock station. And it was a really kind of fun project to do. And here at Waymo, I also get to develop kinds of robust solutions to challenging problems, but they're in a slightly different flavor. Now they're more of like how the car should interact with a pedestrian, or like how to navigate down a narrow road. But robustness is really, and safety is really at its core. So I guess finally, before we start the presentations, I'd like to ask you to give some advice to our audience. You're both leading experts in autonomous driving technologies. What would you say to someone interested in a career in autonomous driving technology? Is there anything in particular you'd recommend to people do to gain experience in the field?
So my advice would be always be learning. The AV industry is constantly evolving, and so are the outside factors that influence the industry. Therefore, my advice is to continuously and actively learn, figure out what we know less of, and seek out resources that help us build knowledge in that area. And this includes both domain knowledge as well as generalizable knowledge in areas like interpersonal skills, strategic thinking, business, and finance. Breadth enables us to predict a range of possible future outcomes. And of course, I think about predictions because, I work in predictions. But this helps us predict what will happen in the world to some extent. And then it helps us to create new opportunities at the right time. And in addition to acquiring breadth, I also suggest building deep expertise in one core area. This has stood me well in my career. By doing this, if we have depth in an area, we feel that we have a very solid foundation to build upon, and it also makes our skills well sought after in the industry. And of course, these days there is no shortage of resources to learn. We do not need to go to a university to learn. There are so much available just online and free for all. Samsung, what's your advice?
Yeah, totally agree with you, Shilpa. My additional advice is like just to learn about the opportunities and apply for the positions like whenever you see meeting some of the requirements in the job description. So not necessarily meeting all of the requirements. So the AV industry looks for a lot of people with diverse backgrounds. Some may require more domain knowledge, and some may need more generalized engineering skills or other or skills in other domains. So just as Shilpa mentioned earlier, right? So for example, I think one place you can start with is to look at Waymo's website, like Waymo.com. There we actually has a lot of information about the journey we have made so far from 2009 as the leading company in this industry. So it can help you to learn a lot about like the history of this industry and the progress made so far. And there are also various blog posts on both technology and user experiences in the web on the website, and also opening roles in the company. Just check it out and apply if you feel passionate about the missions and roles, and then you can start from there, learn more from there. Yep. Allison, handing over back to you.
Yeah, I guess my advice would be to just get started, which I know is like can be like the hardest part of the whole thing. The AV industry actually needs a lot of people with very diverse backgrounds that you might not realize. But skills in adjacent areas such as video games or image search, like Concong, are also really valuable to autonomous driving. I think if you want to learn a little bit more about some of the challenges in autonomous driving, you can do things like look at the Waymo Open Dataset as a good starting point. It includes a Colab tutorial to help you get started, and you can learn about the types of data and things that autonomous people that in the autonomous vehicle industry will look at and want to understand better. Well, thanks, both of you, for your perspectives. And to our audience, if you have any questions of your own, please do leave them in the chat, and we will answer some more questions at the end. In the meantime, on to our short technical talks. Over the next 45 minutes or so, Concong, Shilpa, and I will each share insights into the part of the Waymo Driver we work on to give an unprecedented look at the technologies that are shaping the future of autonomous driving. Concong, you're going to kick us off with a talk on how the Waymo Driver perceives and understands the world around it.
Yep, thanks, Allison. So let's get the slides on. Hi, everyone. So in the following, I would like to share with you how we build a scalable perception system for autonomous driving in Waymo. So let's kick off the slide. Next slide, please. Yeah, so in a self-driving car system, the first question to address is what's around me, right? So from like our sensor inputs as well as some prior map knowledge, we need to reconstruct a model of the world around us, and which involves like detecting pedestrians, cyclists, vehicles, understanding their motion states and activities, as well as understanding the scene level features such as like traffic lights, lanes, construction areas, and so on. So the outputs of perception will be used to predict the future trajectory of these objects and also to plan for the self-driving car's desired path in the later stages. So let's look at the next one. So scaling the autonomous driving stack faces multiple dimensions of challenges, and perception will be the first system to handle many of those challenges directly. So the first challenge belongs to the different vehicle platforms. Waymo now operates two vehicle platforms for the Waymo One service. One is the Pacific Car platform, and the other one is the Jaguar I-Pace. And at the same time, we also operate Waymo Via, which is the trucking platform. So the sensor switch and placement vary across these different vehicle platforms. And then now let's look at the next challenge. Not only the variety in the vehicle platforms exists, the sensor also keep evolving. So for example, last year, we introduced our fifth generation sensor suite. This includes even more powerful LiDARs, which sees up to 300 meters, and the camera system covers 360-degree long range and occlusions. In addition, there is an imaging radar system that offers unparalleled resolution, range, and field of view. So the input data can look very different when we have significant sensor updates like this. Many perception algorithms are machine learning driven and hungry about data. So how to fast bring up a new sensor suite is a big change in scaling. So let's look at the next. Another change is to scale is that Waymo Driver handles diverse operation domains, from suburban to dense urban to freeway to various weather conditions, including fog, rain, and snow. And beyond that, on top of all this, the Waymo driver also needs to achieve very high safety standards because we operate a real public transportation service without drivers. Therefore, we need to have the ability to understand rare events. For example, pedestrians can appear anywhere and dress very differently. They can appear in a manhole as shown in the top left here, or hide themselves in the T-Rex costumes. And we also need to decide what to do on a stop sign carried by the moving cyclist in front of us. And we also need to react properly to a pig dashing across the road. And so these long tail events, they can happen like once in 100,000 miles or even once in a million miles. So let's take a quick look at this video. So we detected a green light, and then we are about to move forward. And then the car in our neighboring lane actually moved forward. Maybe you can play the video again. Yeah. So if you play the video again, you can see that like actually there's a red light runner from our left when we just about to start driving. So in this case, it's very critical for perception to detect this red light runner immediately, even when it was like partially occluded by the car next to us. And also like estimate its motion and speed accurately and timely. So only with that, the behavior prediction system and planner system later can make the right decision. So therefore, like to summarize, at Waymo, we need to build technology and systems that quickly scale to all desired combinations of sensor suites, vehicle platforms, and operation environments, while meeting the high quality standards for safety. To scale such a system is very challenging research and also engineering problem. So how do we do that? So I'm going to share with you some of the key principles in our approach. So the first one is to design our stack with safety at its core, using advanced sensor suite with LiDAR, radar, and cameras, all of which we develop in-house. And secondly, we develop our system by applying state-of-the-art machine learning techniques to leverage the large scale of data we have. And at the same time, we complement this approach with expert domain knowledge to achieve overall robustness and safety. And third is to develop scalable machine learning ecosystem to enable higher efficiency and effectiveness in development. So I'm going to dive a little bit into each of those. So first, let's take a look at the advanced sensor suite we have been building at Waymo. In the next page, so here, since Waymo is founded, we have emphasized a thoughtful and safety-conscious approach. So it is an integrative approach where we design both hardware and software in-house. So we leverage a trio of very powerful sensors, camera, LiDAR, radar, and they are complementary to each other. So for example, LiDAR and radar are active sensors and a great safety feature. So they ensure if some object is out there, we will see it. And at the same time, camera can help to capture more nuance of those objects like human gaze and visual signals like traffic lights and vehicle turning signals and such. So this complementary design to the perception sensors and system is very important because they are the foundations of your real-world understanding. If you don't detect the objects accurately or get your semantics right, your high-level reasoning and decisions will also suffer. So this is a short video showing a scene captured by our latest new generation of sensor. There's a significant boost in terms of like range, field of view, and point density. So the point cloud carries more information than our previous generation of sensor, which you can see from the next slide. So this one was the older one, like it was the previous generation of LiDAR, which has lower point density and range coverage. So now the question comes, it comes to one of the challenges we mentioned in the beginning of the talk. How to adapt a new sensor suite quickly is really critical to our scaling. So as shown here, normal development will require a large amount of data and labels to achieve high quality perception. And moreover, as quality gets closer to the required bar for full autonomous driving, we will need even more diverse and long-tail examples to materially improve the system. So such examples can be very time-consuming and costly to collect. So how can we deal with it? Our approach at Waymo is to develop effective domain adaptation. So domain adaptation allows us to speed up development for new domains using existing data collected from another domain. For example, with the previous generation of sensors. So there are two phrases where domain adaptation can be really helpful here. One is in the initial bring up phrase, a big portion of the knowledge can be quickly transferred to the new domain for it to be functional. And then the other is in the long-tail development. Transferring both the knowledge and data can significantly reduce the amount of time needed for long-tail data collection and development. So developing these techniques in the past year allow us to quickly ramp up our latest sensor suite and achieve even higher performance with a much shorter window than ever before. So now I'm going to talk about the second aspect in our approach, which is to power our solutions with the state-of-the-art machine learning techniques. So as you know, machine learning is a great tool to handle the world complexity, assuming that we have the data to learn from. And then we have years of since we have years of driving experience and capturing diverse scenes in high resolution over time in Waymo. So this is a very rich training signal. But at the same time, the requirement for robustness to extremely rare cases also drives the need for machine learning to be complementary with expert domain knowledge. Sometimes it's challenging to learn from only a very few examples, but handling rare situations robustly is key to safety. The autonomous stack needs to leverage the strengths of machine learning and also mitigate its weaknesses. So over time, the scope of machine learning and specifically deep learning has grown a lot in Waymo. And now there are major machine learning components in every major system in Waymo's software stack. Perception is particularly machine learning driven. Each of our models benefits from cutting edge model architectures and state-of-the-art research. So here I'm going to show you a few examples. The first one as shown here is on object detection. So together with Waymo research, we developed the state-of-the-art detection approaches such as RSN, which is called range sparsenet on the left for 3D LiDAR object detection. And also we developed WIDAR, which is short for visual detection ranging model, which is used for camera detection and scene understanding on the right. And in addition, another example of work we published in CVPR 2020 is to do simultaneous pedestrian tracking and trajectory prediction, with a spatial temporal interactive network. And then beyond detection and tracking, to enable Waymo Driver to provide a much more natural, comfortable, and predictable experience for both our riders and others with whom we share the role, we need to better understand many nuances in the scene. So for example, detecting the open door of the car such that we can nudge around it more nicely, or understanding the pedestrian's intent to cross the street in front of us based on their pose. So the field of machine learning has been changing very rapidly. Waymo is in a unique position to contribute to the research community with some of the largest and most diverse autonomous driving data sets ever released. Since the launch of these data sets in 2019, Waymo Open Dataset has been growing over time and now contains both a diverse perception dataset as well as a motion dataset with object trajectories and 3D maps. So we have released all this publicly to aid the research community to make advancements in machine perception as well as autonomous driving technology. So now the last but not the least I'm going to talk about is the scalable machine learning development. So I think in order to explore the large set of machine learning solutions, as we mentioned earlier, we need a scalable machine learning ecosystem to allow us to develop and iterate and deliver those solutions efficiently. So from data collection to labeling, training, testing, validation to deployment, we developed this machine learning factory to streamline all the stages. We are currently also working on automating the whole cycle, which will also enable us to iterate even faster and improve continuously with minimum engineering efforts. So to enable this factory, several key ingredients are necessary. One of that is to scale up data in terms of both scaling up labels as well as scaling up the data diversity. So I'm going to give a few examples. So the first one is to scale up data with auto-labeling techniques. So in this example, we developed the auto-labeling pipeline to emulate the process of a human labeler labeling 3D objects. So it uses the whole sequence of sensor data and generates highly accurate boxes and tracks as shown here. So these boxes and tracks can be used as labels or used as data augmentation in training. It is also often more robust to domain shifts as well. And the next, another way to scale up data is to do sensor simulation. Sensor simulation is a critical technical component to enhance perception training, especially on long-tail cases, in addition to enabling realistic end-to-end simulation for the whole system. So we have LiDAR simulation as shown here, which we need to closely represent the LiDAR characteristics. It's not just geometry. More importantly, LiDAR simulation needs to learn and simulate sensor returns on different kinds of objects and materials and be able to create realism. And we also do camera simulation in Waymo. So here's a rendering of our camera simulation. On the left is the real camera image. On the right is the simulated camera output. And if you look closer, you will find that the shadows of the building and light poles actually match very closely with the reality. And we have accurate models and textures for buildings based on the 3D data collected by Google Geo. And we have also accurate placement of all the scene props like the fire hydrants and also the light poles from the 3D maps we have collected. And last, we also simulate the sensors under weather conditions. So there are different types of weather conditions, and for each of them, there are different degrees of it. For example, for rain, there's light rain, medium rain, and heavy rain. And for fog, there is different visibility levels. So it's impossible to collect the same set of diverse real-world driving data under all weather conditions. So therefore, being able to simulate them is very important. So on the left, you can see that like it is the camera with simulated raindrops and wiper. So as the wiper sweeps through, and you can see the raindrops go away. On the right, it is the point cloud with the simulated fog effect. So beyond auto labeling and sensor simulation, we also have various other techniques to scale up our development cycle, including a lot of improvements in tooling and infrastructure for both training and evaluation process. So with that, I would like to conclude this talk, and I would like to thank everyone for your listening. So next, I think I'm going to hang over to, okay, go ahead. Yeah, I'll hang over back to Allison.
Thanks, Concong. I think that's a fascinating thing. I hadn't realized that we did so much for image scaling, or scaling up the image pipeline. As you just heard, the perception system is the foundation for everything that comes afterwards. Without good perception, it's not possible for autonomous driver to understand what's going on around it and what it should do as a result. The next layer of understanding after perception is behavior prediction, where our vehicle knows what's going on around it. Once our vehicle knows what's going on around it, it then needs to work out what's going to happen next, so it knows how to react appropriately. Is that perception looking at their phone on the sidewalk about to cross the street? Or, for example, waiting to be picked up by the Waymo Driver? Is that motorcycle going to be merging lanes? And is that car going to run the red light? Our behavior prediction system helps the Waymo Driver answer these questions. Shilpa heads the team working on these technologies and has a short presentation for us now. Shilpa?
Thanks, Allison. I'm going to talk to you about behavior prediction. Next slide, please. So before we get into it, let's put ourselves in an imaginary driving situation. So imagine for a moment that you are driving in this situation. You see a motorcyclist pointing toward the road. What do? You try to figure out what the motorcyclist will do next. What is the chance that the motorcyclist will cross in front of you? What is the chance that they will wait for you to proceed? This task of predicting future behavior of others around you is called behavior prediction. Before we go deeper into how the behavior prediction for the Waymo Driver works, let's understand the intuition behind prediction. What is prediction? A prediction is a probabilistic assertion about a future event. It is probabilistic because we almost never have all the information needed to make deterministic predictions. As an example, numerical weather prediction models use current weather observations to forecast weather. Current weather observations are obtained from sensing systems like weather stations, satellites, radio sondes, all of which have uncertainties in their measurement. Additionally, all variables needed for weather forecasting cannot be measured directly. So therefore, prediction by necessity needs to be a probabilistic prediction. Now, why do we need to predict? Prediction is necessary to plan rewarding future actions. For example, if the weather prediction says that it is going to rain today, we will take an umbrella so we don't get wet. Now, how do we do predictions? Previous slide, please, for a second. Yeah. What we do is we build predictive models from observed data, and we do this in a variety of domains. Some examples are weather prediction, traffic prediction, economics forecasting, etc. Moving on to how the Waymo Driver does behavior prediction. Next slide, please. So behavior prediction for the Waymo Driver, it answers the question, what will happen next about the world around the driver. So now let's go deeper into what this means. Next slide. The goal of behavior prediction is to predict possible future trajectories of all other relevant road users around the Waymo Driver These include different types of agents like cars, pedestrians, cyclists, pedestrians riding on a skateboard, and so on. The prediction generally covers a time horizon of up to 10 to 20 seconds into the future. Behavior prediction takes the output of perception, as Song described, as its input and provides predicted future trajectories as input to the planner. Accurately predicting the behavior of other road users is one of the hardest problems in autonomous driving. Here is an example that shows what makes this hard. Here, the Waymo driver is driving next to two cyclists represented by the boxes in red to our right. We need to model the intent of the cyclists, which we cannot observe. We also need to model how the cyclists will interact with each other and how the other cars will interact with these cyclists. Further, we need to model any road users that may be hidden behind the parked vehicle. As we saw earlier, predictions are necessary to plan rewarding actions. In case of autonomous driving, behavior prediction also has significant safety implications. Correctly evaluating another driver's likely behavior is essential to being able to mitigate crashes. Next slide. So now getting a bit deeper on how behavior prediction works. This is the input of behavior prediction. It takes the output of perception, which is very rich. It consists of object information, construction zones, traffic light states, key points, gestures, and much more. It also takes a road graph as input, which consists of the road topology and geometry, location of traffic signs and signals, and much more. The green box at the bottom is a car. It is approaching an intersection. The lines in this figure show us the road graph. And as you can see, these lines represent a variety of rich information. We have dotted lines, we have solid lines, we also have lane connectivity. Our goal is to predict what the car will do in the next few seconds. As I mentioned, there is a challenge of prediction when we don't know the intent of the driver. In this case, the intent is confusing. This car is straddling two lanes, so therefore it could go straight, it could make a left turn, it could go right, or it could stop. We need to model this uncertainty, and therefore we predict a distribution of trajectories with likelihoods. Next slide. Now this is an example output in the scenario. Here we predict multiple future trajectories. All the predicted trajectories are shown in green. The darker the color, the higher the likelihood. As we see in this case, we are predicting a higher likelihood of driving compared to other actions. We do this for all relevant objects around the Waymo driver. Next slide. And if we do this, when you put it together for all objects, it is a lot. This information is then used by the planner to reason about the world and make progress safely. Now, how do we solve behavior prediction? Looks like a challenging problem. And as Song said, similar to perception, we leverage domain knowledge, robotics, and machine learning to solve behavior prediction. Our algorithms are informed and learned from over 20 million autonomous miles on public roads that have been collected by the Waymo fleet. To evaluate our algorithms, we use ground truth from our logs as well as the billions of miles that the Waymo fleet has driven in simulation. Here is one possible abstraction of what an ML architecture for behavior prediction can look like. Of course, things are never stable here, they evolve, and in 2 years, this architecture may look very different. We independently encode information about the road, history of the states of other road users, and their interactions, and then fuse these encodings. A trajectory decoder then computes kinematically feasible trajectories. It is very important for the trajectories to be realistic. The output is a distribution of trajectories with their likelihoods and an uncertainty distribution for each trajectory. Slide. Now here is an example showing the Waymo driver predicting the motorcyclist that we saw earlier and safely reacting to it. Here is an example of a Waymo driver sharing the cyclist and being very polite with them. Here, of course, we need great perception. We also need robust prediction capability to predict the intent and model agent interactions. Here is an example of the red light runner that Concong shared. These kind of examples are relatively rare, yet we can train our models to predict and react to such rule violating agents. And to learn more, I would like you to point to a few resources. Song already pointed out the Waymo Open data set. Uh, in addition to perception, it also supports research into behavior prediction. Generating a motion data set with high quality labels requires a sophisticated perception system that can accurately pick out agents and objects from camera and LiDAR data and track their movements throughout a scene. Interesting motion data is also hard to gather. Most day to day driving is uneventful, which makes for uninformative data when you are building a system to predict what could happen on the road in unusual situations, such as the red light runner. As a result, existing data sets often have a limited number of interesting interactions. The Waymo Open dataset seeks to address these challenges with object trajectories and corresponding 3D maps for over 100,000 segments, each 20 seconds long, and mined for interesting interactions. Our motion data set contains more than 570 hours of unique data. We believe it is the largest data set of interactive behaviors yet released for autonomous driving research. And of course, we aim to continue to grow this data set. Yeah, I also want to share with you a couple of papers we recently published. These are results from a paper titled Multipath, which was published in 2019. This paper presented a deep learning model for behavior prediction. We have since continued to build on this. Here we show some results of one of the versions of this model. On the left is a complex intersection case. On the right is a densely packed parking lot. The current version of the multipath model is at the top of Waymo Open Dataset leaderboard. You can, I forgot to add the link, but you can Google it and you will find this paper if you would like to learn more. Next slide. Another paper I would like to point out is Scene Transformer. This model is inspired by large-scale language models. The goal is to formulate a model for prediction that models all the agents jointly. So instead of trying to predict every single agent separately and modeling interactions indirectly, here we do the joint prediction, which ultimately may be the right and the most powerful way of solving behavior prediction. This can generalize to many tasks from a large model trained on a huge data set. It uses transformers to learn interactions and integrate information from road graph. And again, if you are interested, please Google it. I forgot to include the link, but it's there on Google. Thank you so much. And now I hand it back to Allison.
Yeah, that was really fascinating, Shilpa. Thank you for sharing all of those resources with us. Once the Waymo driver has an accurate sense of what's happening around it and what's going to happen next, it then needs to decide its next move. That's where my team comes in. So my team is the planner. Next slide. After we know what's around us and have a good idea of what they're likely to do next, we ask ourselves, what should I do? This step is called planning, and it's what enables the car to successfully and safely drive from point A to point B. This is an example of the Waymo Driver in action in San Francisco. These scenes illustrate the typical challenges of urban driving. One of the main challenges is the sheer complexity of environments, scenes, and human behaviors that we encounter. Handling things like this interaction down a narrow street, other interactions with pedestrians that are jaywalking across the street. We have to recognize what they intend to do and stop for them. And then scenes like this that are actually really complicated with lots of cars, cyclists, and pedestrians. We even have to understand, gestures that the cyclists and pedestrians might be using to navigate the road. This is just a small sample of interactions that a car typically encounters, and we'll dive a little bit deeper into a couple of them later on. We can see here we're passing a couple of double parked cars that are down the street, but we know that it's safe because we have all of that great perception and sensing technology. Cool. So my team's mission is to consume information about the world so that we produce a trajectory or plan for the Waymo Driver to execute that ensures safety, progress, and quality for the passengers. To start with, let's break down the planning components. First, there's reasoning. You can think of reasoning as a topmost layer in our technology stack. It takes in all of the inputs from the rest of the system, things like perception and behavior prediction, and outputs a robust formulation of the planning problem that needs to be solved this cycle. That problem is then passed into the trajectory generation system that solves for a candidate of trajectories in space and time so that we can navigate there successfully. And then once those trajectories have been generated, they have to be selected. The correct one or the best one is then selected for the car to actually drive. All of this work is done in close collaboration with evaluation, infrastructure, machine learning, and simulation. The inputs of the planner are all of the upstream modules. So including some of those that you heard about today, perception and behavior prediction. Planner also uses information about the road, including things like dynamic blockages, things like construction zones, and our current location in the map, and our desired route, so that we can successfully get you from point A to point B. The planner then outputs things like the trajectory the vehicle should follow, vehicle commands like blinkers and lights, and logging information to help us understand the vehicle's internal state. Now that we've gone over the kinds of inputs and outputs expected from the planning system, let's take a look at an example. I'll start with something relatively straightforward. We have a pedestrian approaching a crosswalk at a four-way stop. This isn't even a particularly noteworthy interaction for most human drivers, but there's actually a lot going on here. The pedestrian's approaching the crosswalk and road edge, but is stopping. Do they want to cross? Are they slowing to let the car go first? Or are they slowing, waiting to be invited to cross by the Waymo Driver? Both of these can look exactly the same if we're basing that understanding on simple features such as geometry, proximity, and speed. But we've been working hard on adding really robust signals and learning more about the semantic nuances and social expectations at play here. Perception captures the intent of this pedestrian to cross in front of the car, and planner uses that to model the appropriate response. So not just what the pedestrian is actually doing, which is slowing to stop, but also their intent, where they would like to go. Here we understand that it's a nice, polite, low discomfort behavior to accommodate this pedestrian, and we remain stationary to let the pedestrian proceed across. It's really almost elegant how simple, seamless, and unremarkable this interaction is handled in our modern software stack. So let's go ahead and take a look at another example. Okay, now this one is a little more complicated. The car is driving down a street with many other cars on it. We're making this turn. There are pedestrians crossing, and then there is this double parked vehicle ahead of us. And we have to reason about things like, is the car ahead of us going to stop in traffic and stay behind them? Are they temporarily stopped and we should pass? Was that pedestrian intending to cross the street to get into the car, or are they going to complete crossing? So bringing out just one frame of this interaction, here we're turning the corner to see when we see two pedestrians on the street. We need to reason about these pedestrians' likely actions, which we get from behavior prediction, and understand also what a good driving behavior might be. So should we stop in the intersection while we let these pedestrians pass? Is there an appropriate place to stop? How closely should we pass beside them or behind them? And what is the most comfortable way we can make this interaction? We use things like their behavior prediction and our perception signals to understand that they are crossing the street and that they will be out of our way by the time we complete our turn. Now, those examples I showed you are actually quite common, although some of them were a little bit complex. But let's take another look at that red light runner case we saw earlier. So not only did we have to accurately detect the car approaching the intersection that they were going to run the red light, we also had to plan our best response. This involves both understanding the normal response to a green light, which is go, but also being able to adjust the plan to prevent a collision, so stopping for the red light runner. While this interaction isn't common, there are even more rare events that we have to think about in the long tail. Let me show you now a really long tail scenario. So disclaimer, nobody was harmed in this scene. So take a look at this. Did you see it coming? Let's look again a little bit closer. And this video has been motion stabilized and zoomed in on this motorcycle at half speed playback so you can see it a little bit better. This is an extremely rare event, one that would have had the potential to have very severe consequences. So how do we keep the Waymo Driver safe? We do extensive testing of the planner and of the system. We can test our software on public roads under the supervision of a trained vehicle operator. That allows us to test how it interacts with other road users and gain new experiences from the real world. However, as we evolve our system, we may have to drive tens to hundreds of miles to capture more and more rare scenarios. So real-world driving, as crucial as it is for system development, only scales up so much. One thing we can do to help with rare scenarios is we have a 91-acre test track on a former Air Force base nicknamed Castle. By providing realistic data about situations that are encountered less than once per million miles of driving, we can help ensure our driver responds safely during rare occurrences. Additionally, simulation at Waymo is used extensively for validating the performance of new releases at scale. Simulated scenarios do not really expire and can be used to compare autonomous vehicle algorithm variants. And of course, simulation can provide important supervision signal for machine learning algorithms, which we've been incorporating into our planning. And that concludes an overview of the planning system.
Thank you for the fascinating talk, Allison.
And thanks again to you and Congcong for fascinating talks. I hope you all found them as fascinating as I did. We've got time for a short Q&A of our speakers. We received a lot of questions from you, and I saw many questions pop up in the chat as well. You can still submit your question if there's anything you wanted to know about autonomous driving technologies or how to break into a career in the industry. Now is your chance. Okay, so first up, what are the skill sets one might need to start their career in this industry? Also, for new grad applicants, which do you value more? His or her past experience, skills that already fit the project and can be used right away, or his or her potential learning ability, even though she may not have the right knowledge for now?
So I can start. So first, like as Allison and Congcong already said, right, we look for a diverse set of skills. Autonomous driving involves a lot. It is like it involves engineering in several disciplines. It involves operations, legal, policy, marketing, and a lot more. So we look for people with a diverse and interesting set of background. So definitely there is some skill matching to the roles. That said, I'll say if speaking from my engineering perspective, it is always good to have a strong math and engineering background. I personally also look a lot for learning ability because, as I said, the autonomous vehicle field is constantly evolving, and if we cannot learn, the tech we are on becomes a dinosaur. So that ability is absolutely, I think it is number one that I look for personally.
Yeah, I can just briefly add something on top of what Shilpa just said. I think it's very important when I'm looking at candidates. It's very important for candidates to be passionate about the mission. And I figure that like if you are passionate with that, like you would really like motivate yourself to learn new things and also expand your skills. And just as Shilpa said, like for the exact requirements always depend on the role. But at the same time, like we also have so many diverse roles. Some may require more like specific domain knowledges, like in robotics or in machine learning, in computer vision, and in planning control. But some of them are more like improving, like the scalable system, infrastructure and tooling. So those can be more generalized engineering skills. So we do have a lot of like diverse roles, and if you are interested, please take a look at those roles, and we'll be also happy to really hearing from you if you are interested.
Yeah, I couldn't agree more with both of you. I know Waymo is hiring a lot of the diversity of experience is what we're looking for, and having a real passion for the technology or the industry in general, I think is also super helpful. How about another question? How does ML need to evolve to support the car's learning to drive in the toughest conditions, say at night in the rain on unmarked road in the Smoky Mountains?
Congcong, I think you should start that.
Yeah, I can start that, and please add more on top of me. So I think for machine learning to thrive, like one very important aspect is data. So therefore, like getting the right data is very important. And how to get the right data also needs us to be creative. Like it can be like, as I mentioned earlier, that like we can develop the technologies to better actually like to get our cars to drive more clearly, to collect the long tail data, and then like also to have dedicated like toolings like to better mine out the data and have like the machine learning algorithm to better augment the data during training. So all this that we can employ a lot of like machine learning technology to improve those. And on the other side, there's also like we can also like create new data. That's related to like what I just mentioned, like sensor simulation. So we can leverage those, like even to generate like synthesized data at the real world quality in order for us to use for like expanding our data set and then use them to help our machine learning algorithms to learn better. Yeah, I think so. I hope this answers the question. And maybe anything Shilpa or Allison you would like to add?
Yeah, I can add one more thought. It is very important for us also to be able to detect out of distribution cases, right? So we build models to discover these out of distribution cases. In addition, we want to be very robust to anomalous situations, which means we want to build our models that are self-aware, in the sense that they can detect where they are going wrong. In the case of predictions, one can look at the evolution of the world and compare the predicted futures and then use that to build models that flag when a model is not performing as well. And then that situation, the planner can act much more conservatively.
Yeah, I agree. I think for planning, a lot of the challenge comes in being able to replicate situations, and we can do that pretty easily with our sophisticated simulation architecture. So we're able to recreate situations that we've seen on the road, but add like a little bit of a difference. So we can, change the positioning a little bit. We can change the speed a little bit, and we can, then test for some of the robustness of our planning. Because here's another question from our live chat. A challenge of deploying AVs in the interactions of all the different road users and ensuring their safety. Recent work has developed algorithms that run in real time and find safe trajectories and the controls that produce them. Are these some ideas that are used in motion planning or being talked about? I guess I'll take that one since it's a planning question. I think we do keep up to date with all the latest in the industry. We incorporate a lot of those kinds of like robust planning ideas inside of our planning solutions. And we're also leveraging more and more like data at scale in some of these machine learning techniques that are coming down from the research groups. You may have heard Drago talking about some of the work that we've been doing in the Waymo research side that involve a lot of like using simulation to really understand like what good drivership is and be able to replicate a lot of these driving situations on the road. That really enables us to drive in a much safer way and be able to test out all of these kind of corner cases that are really tricky to actually like elicit from on-road driving. Here's another question. Autonomous cars are seen as something novel. How do you think the acceptance has changed since you started working in this field?
I can try to take this one. I think we believe that the technology only realizes its full potential only if the public trusts the autonomous driving technology. So therefore, we see it as like it's our responsibility, like to help educate the public on this technology and also the safety, mobility, and economy benefits it can bring. So from my experience at Waymo, right? So as you might know that like Waymo recently published our safety framework when we launched the public service in Phoenix. So this is one of like the ways that we would like to do to educate the public by sharing more about like how we think of like the readiness and metrics and standards to deliver a fully autonomous service. And then And at the same time, I think the open of this public service also is another way to give experiences to the public and also get learnings and get feedbacks from the public. So if imagine that like if the publics now they can basically they can take a ride in the Waymo car, they can experience this, they can feel how safe it is in this autonomous car. So then like this is a really like effective way to educate the public by getting them into the car in reality. I think that's why Waymo we are so serious about like all our safety priority and really like delivering this public service as like the I think it's the first one in the world like to deliver such a service. And at the same time, like we also over time we learn a lot of feedbacks from the users on how we can further improve our user experience and so on. And those are super beneficial for our continuous development. So I think only with that, like these iterations by we open more, we get more interaction with the public, we share more, and then we also learn more back from the public. We can gradually reach to the level that like we also earn the trust from the public for us to eventually scale up the autonomous cars in the world.
Yeah, Shilpa, I know that you said that you had your child ride in a driver one of the Waymo One cars in Phoenix. What made you feel comfortable enough to do that? How did you accept that?
Yeah, good point, Allison. So I think it is what Song said, the emphasis on safety. So I'll say safety is in our DNA, right? Every single engineer every day feels compelled to make a safe product and to raise any concerns there may be, right? So this safety is in the DNA, and then we have implemented a set of tests that give us confidence in our ability to drive safely. And these tests go all the way from unit testing of software to testing in the real world with our trained autonomous specialists. So given all this emphasis and having seen all the numbers, I was pretty confident that this is not only going to be safe, it is going to be comfortable and an uneventful ride, which it was. The wow factor was there for the first few seconds because there was no driver. There was truly no driver, and I'm trusting myself to a car. But within 5 minutes, we were all comfortable. We were chatting and just, didn't worry about the driving. And as Song said, this is what we need. As we have users who take our rides every day in Phoenix, and as we continue to deliver, I believe over time we'll get more and more confidence from the public.
Makes sense. Here's another question. Were all three of you aces at math?
Well, I'll say I kind of was. So I'll say I am a mathematician engineer. I cannot compare myself for the world class mathematicians out there, but I did well in the math that is needed for engineering.
Yeah, same for me. I don't know whether I really qualify for acing at math or not, like, but I did pass the entrance exam for me to be qualified at like doing electrical engineering study in my undergraduate.
Yeah, I guess for me, I think I was also probably pretty good at math. I actually really loved math growing up. To me, it was the subject that, it was either right or it wasn't right. And so it seemed less arbitrary for getting like the right answer. Whereas some of the like longer form, English where you have to write an essay or something, sometimes you get like points taken off and you'd be like, but why? I like understood the concepts. And so like it being like, oh yeah, the answer was 3 and I put down 3 and it was right. It was appealing for me. So I really enjoyed math. I don't know that it's necessarily a requirement to like be in the autonomous vehicle industry that you have to have been good at math. I know other people have different experiences with math growing up where, I guess like as a woman, maybe you're told that you're not that good, like you shouldn't be good at math. That wasn't my experience. In my schools, like the top students that in the class were women, so were other women. So it was kind of be like, well, I got the right answer. What do you mean we're not good at math? It wouldn't have really like made much sense to me. Yeah, I don't think it's a requirement, but yeah, I did really enjoy math growing up.
Yeah, that's great, Allison. I think I agree. The right or wrong part of math was one of the things that also drove me to it, because the feedback was clear. Either I knew it or I didn't.
Yeah, let's see another question. I've seen a lot of Waymo vehicles around with a lot of LiDAR cameras attached to them. At what point will the cameras disappear?
I think I can take this one. So as mentioned earlier, that we have our hardware and software all developed in-house. So therefore, our hardware development and design benefits from our over 20 million miles of on-road, and also the understanding of the edge cases that self-driving cars need to be able to handle in order to take people and things safely from A to B. Just like a person's five senses, each of our senses actually complement the others, and they have very different strengths. So for example, cameras are great at seeing colors and details like traffic lights. I also mentioned a vehicle turning signals, and also like capturing a lot of details like pedestrian skates, like and a lot of like the activities they are doing. And while our imaging radar, they can detect an object's range and size, and it's more resilient in a wider range of weather conditions. So I also talk about like the LiDAR's strengths in detecting objects and also with details, as mentioned in earlier of the talk. So therefore, for now, we really recognize these complementary effects of these different sensors. We would plan to continue using of the cameras, LiDARs, and also radars and microphones in our current stack.
Okay, so here's another question. How does the Waymo Driver deal with differences in traffic rules at different geolocations? So I guess there's probably two parts of this. I think there's the behavior prediction piece, and then there is the planning piece. I think we have a pretty good prior, so we do pre-map the intersections and things, so we do know the applicable traffic rules that are in play in any intersection. I think there's an additional component here where like different jurisdictions will have different like rules around like what you can do at certain intersections and like what the laws are there. We encode that into some of the planning algorithms so that we adhere to the local jurisdiction and the laws. That's part of some of the prior knowledge that we can incorporate into our planning stack. I think the second part of that is the behavior predictions. We also want to make sure that the other users, like when we're modeling other users on the road, that they are being modeled appropriately. And I think Shilpa can maybe explain a little bit more about that.
Thank you, Allison. So as you said, it is a prior map. It encodes a lot of information. It is definitely a very important input also to behavior prediction. In addition, we have tried to move more and more away from heuristics, because the more heuristic-y approach, meaning the more we try to hand code rules, the more complex the software gets. So the idea is to hand code what is only necessary, and rest rely on data and machine learning, because that's what allows the system to scale and to generalize eventually.
That makes sense. How about another one? What is your release model? How do you verify release is ready for production? to complex real-world environments?
Yeah, thanks for the question. I think this is a good question because one of the really important change for self-driving cars is that to decide when it's ready to release a model to the production. And as I mentioned, we over years, Waymo has built up a comprehensive safety framework to verify and validate each of our releases. And in order to do so, basically, every time when we cut a release, it needs to go through really comprehensive testing and validation. And that's why it's very important for us to have the whole simulation engine that can simulate millions of miles to test the software even on the simulation data. And at the same time, we also have many comprehensive metrics to measure the different aspects of the software, including, of course, the safety part, but also the quality and the smoothness and the progress. If you are thinking about this is a service to bring people from A to B. So we need to measure all these different aspects before we release a software version to the production. So therefore, it needs to go through really comprehensive process, and that is where we spend years to learn the experience from our driving and our development, and to build up the framework there. And I actually view that as a big advantage of Waymo's infrastructure and framework to allow us to develop our system more robustly before releasing to the real production.
Yeah, I know one of the things I really value about working at Waymo is that we do have a writer-only service that's in Phoenix, and so there is a lot of testing and validation that has been developed and that has been stress tested and that actually works really well. And so when I'm making a change in the software, I know that there are safeguards in place to make sure that the changes that I'm putting in are giving a positive impact on the driving performance.
Yeah, actually, I would like to echo that this is actually an area that we still need significant investment over time, and if people are interested in contributing to that, we would like to hear from you too, because it's so important. And while Waymo trying to scale up our Waymo Driver to more applications, to more regions, there will be a lot we need to improve in our safety framework too. So yeah, so if you are interested, please talk to us.
Cool. So how about we move on to another question? Here's another one. Are there any online resources you'd recommend to develop the skills needed for the field?
Yeah, so I can start. I'm sure we all have a lot. So first place I would say is to start with reading papers. So there is a lot happening in industry now. A lot of papers are being published. There are a lot of good conferences. So I would suggest starting with the top ML conferences, following the papers in autonomous driving. Uh, Many of the companies in autonomous driving, including Waymo, we have a blog. We constantly share what we have learned through various video series. So that would be another resource to start from Waymo's blog. There is a lot on the Waymo driver there. And then finally, there are many courses on autonomous driving. There are open source courses that we can start with. Um, and then I would say a general fundamental knowledge of machine learning is very good to acquire, especially when everything is moving towards machine learning.
Yeah, I think Shilpa covered it very well. I just want to add that the skills needed for the field, as we mentioned earlier, is very diverse. So not many of the skills are not unique in self-driving. So for example, we also need a lot of generalized engineering work, and a lot of like tooling infrastructure development for this like large scale system. So like even like for example simulation, sensor simulation, we might even can leverage the skills from like the gaming industry and such. So therefore like we like to develop the skills, like because the skills are very diverse, the way to develop the skills, the resources to develop the skills are also very diverse. You can find the corresponding maybe online resources or offline courses like related to the roles you want to target for. So yeah, so that's my also like some of the complementary ideas you can think of.
Yeah, I think I agree with both Song and Shilpa. I think that there are many like open resources that you can look at to learn more about the technology behind self-driving cars, which I think is super beneficial for getting a job in this industry. I guess I would say that the things that are moving pretty quickly within the field are things like ML. So if you are keeping up to date with the latest in the conferences, there is a lot of things that are happening there. There's a lot of things that are changing fairly quickly. And so really having that like learning mindset where you want to learn more and learn more about ML and about the industry. I think that there is just tons of stuff to learn, and it's constantly changing. And we also need, other software engineering kind of skills, generalists, people from the gaming industry, people that are familiar with maybe other things within ML that may not exactly be self-driving, but actually translate quite well. I know Song was involved in image search before, so some of the like ML applications, search and ranking can actually be useful skills to have within the autonomous vehicle industry as well.
And yeah, I'll say if you are in doubt of your skills, do apply. I have had many of my friends reach out to me thinking that their skills don't quite translate to autonomous driving, and I got really excited to see their CV because that's exactly what we were looking for. It was a skill set in a different domain, but that's what we needed for us.
Yeah, I know it could be a little bit of an intimidating field to enter into, even for somebody like me who is like has a robotics background. When I was doing robotics and home robotics, but there was always this kind of like, well, self-driving cars are different, and they need to be more productionized, and they need to have like this high amount of quality, and that can be like super intimidating to get into. It actually wasn't that different. I think a lot of skills that I had before really translated over really well. And I think that's probably true for people that are in other domains as well.
Yeah, plus one to that too. So like just to summarize, I also feel that like sometimes the best way to develop those skills is to like work in that industry, like to earn the really specific skills. Like because a lot of like the backgrounds and experience may already translate to get you qualified to contribute to this industry. And then the additional unique skills needed for this field may be the best way to learn while you're working inside this field.
Cool. Well, I can see we have many questions in the live chat, but I think that might be all we have time for today. I know I could keep this discussion going for hours further. And if you have any more questions about anything we've discussed today or careers at Waymo, you're welcome to get in touch with us. Thanks again to our brilliant speakers and to all the other self-driven women, both at Waymo and in the rest of the industry, for building an exciting new future of autonomous mobility. We look forward to seeing you at another Self-Driven Women event soon.
Thanks everyone for joining today.
Thanks everyone. It's been a pleasure.